In a previous video, we talked about linear functions. In this video, I want to compare linear and exponential functions, so I will be defining an exponential function in this video. So a linear function, I hope that you noticed that when we have consecutive inputs, the outputs always differ by the same amount. In other words, if I have inputs 1, 2, 3, 4, then the outputs, if I take their differences, well, in this example, I'm always going to get 3. So what does this tell me about the linear function? It tells me that the slope is 3. So I automatically know that m is 3. That's what this difference represents. Now, here's the specific model for a linear function, and you can verify that this particular model gives me those outputs. But I want to focus a little bit more on exponential functions today. So exponential functions, it's not that the difference is constant, but the ratio is constant. In other words, if I'm looking at these inputs and these outputs, these are consecutive. 6 divided by 3 is 2. 12 divided by 6 is 2. And, of course, 24 divided by 12 is also 2. Those ratios are constant. And that's the definition of an exponential function. So what I would like to do is talk about the form of an exponential function. Exponential functions have the form a times b to the x power. B is called the base. A is the initial value of this function. So let me write this up here. B is the base, and A is the initial value of the function. So the big question comes is, how do I figure out the B and the A? Like, I already wrote down B is equal to 2 and A is equal to 3/2. So how do I actually figure this out? Well, I know the ratio is automatically B. So B is equal to 2. So to figure out A, what I can do is take any one of these pairs. I'm going to choose 1, 3. So I know my output is 3. I don't know what A is, but my input was 1. 2 to the first power is 2, so that means A is equal to 3/2. And that's how I wound up getting y is equal to 3/2 times 2 to the x power. I hope this explanation was helpful. So here's a quick introduction on how to use Desmos for exponential function. The first thing you should do is log into Desmos, and up in the right corner there's Math Tools. Select Graphing Calculator. This will bring up a calculator. Now what you need to do is enter in some data. So I'm going to click on Table, and this is given in pairs, x1, y1. So the example that we had an input of 1, an output of 3. Input of 2, output of 6. Input of 3, output of 12. Input of 4, and an output of 24. Now what I can do is I can ask Desmos to create an exponential function for this. The way we do this, we're going to have the output, y1, and then we're going to put in a tilde. That is on the upper left portion of your keyboard. Do not put an equal sign in there. It's not going to work. Now, what is the model that we want? We want A times B raised to the input, which is considered x1. And as soon as I type in x1, it tells me some things about this. It tells me by parameters. A is equal to 1.5. we had 3 halves in our problem, and b is equal to 2. I hope this introduction to Desmos was useful. So in this example, I want you to consider the following monthly users of Facebook. They're giving from the years 2005 to 2009. I'd like you to figure out the differences, the ratio, and describe the graph that this data represents. I suggest going and using Desmos to experiment with this, at least for the graph. So if we write down all our outputs and then compute consecutive differences and consecutive ratios, this is what you wind up getting. So like this 33 here, this is 58 minus 23. This 2.5 is 145 divided by 58. As you can see, this difference column is definitely not constant. Now, this is where we have to make a little bit of a, kind of squint a little bit. Are those constant? Well, no. Are they very close to being constant? Is the difference on these numbers, these ratios, a lot? No. So I will say this is almost constant. Well, it's a lot more constant than this one. So I will say that this data, these outputs, this follows an exponential model much better than a linear model. So remember, our model is going to look like a times b to the x power. How do we figure out the a and the b? Well, since it's almost constant, I suggest that you go into Desmos. So bring up Desmos, start a table with these in there. And just be warned, there's a little tiny intricate or technical detail that I will be doing in Desmos to make our numbers a little bit easier to read. Alright, let's go to Desmos. So open up Desmos, go to a graph, and I'm going to enter in the data into a table. So we're going to start out with 2005. Now that we have the data in, I want to construct a model of this. So we're going to type in y1 tilde ab to the power of x1. And if you notice that the a and the b, they don't look quite right. So one thing that we should do is kind of use 2005 as a reference point here. I would like to change 2005 into year 0, 2006 into year 1, and so on. So let me do that really quickly. We'll make 2005 0, 2006 1, and so on. And you'll see that we get something that's a lot better. So as you can see on this graph, that we have a concave up. It is increasing. And the end behavior, as the years increase, the number of Facebook users goes to infinity. Now, I wouldn't say this is the best model because, well, there's a limit on the number of Facebook users that we can have. And we'll discuss another model later on. I hope that was helpful.